Hello. I am Tony and I am here to discuss the common network utilities used in resolving network issues. We will test these utilities in solving some common network problems. First, let's talk about ping, traceroute, and IPconfig. Ping is the most commonly used network tool. It is used to provide a basic connectivity test between the requesting host and a destination host. If the requesting host receives a response from the destination host, this host is reachable. This utility is commonly used to provide a basic picture of where a specific networking problem may exist. For example, if an internet connection is down at an office, the ping utility can be used to figure out whether the problem exists within the office or within the network of the internet provider. Ping tests reachability by determining the round-trip time through the use of Internet Control Message Protocol or ICMP. It measures the time to live in milliseconds. Here are the different ping command syntax you can use. Go on, try it yourself. Search for the command prompt on your computer, then type in ping, then space, then slash and question mark. You may pause this video while you try it. Next is traceroute. Once the ping utility has been used to determine basic connectivity, the traceroute utility can be used to determine more specific information about the path to the destination host, including the route the packet takes and the response time of these intermediate hosts. It maps the entire path with ICMP, time to live, exceeded error message, in intervals called hops. The format of each line is as follows. Hop. Whenever a packet is passed between a router, this is referred to as a hop. RTT1, RTT2, RTT3, this is the round-trip time that it takes for a packet to get to a hop and back to your computer, in milliseconds. This is often referred to as latency, and is the same number you see when using ping. Traceroute sends 3 packets to each hop and displays each time, so you have some idea of how consistent, or inconsistent, the latency is. If you see an asterisk in some columns, you didn't receive a response, which could indicate packet loss. Domain name, IP address, it can often help you see the location of a router. If this isn't available, only the IP address of the router is displayed. Let's try doing a traceroute. Open the command prompt, then type tracert for Windows, or traceroute for Linux. Then type in the domain name of the website you are trying to reach. You may pause this video to try it. Next is IPconfig. It helps determine TCP/IP and network adapter information, which then helps us in most of our troubleshooting actions as we have to ping our local router or gateway first. One of the most important things that must be completed when troubleshooting a networking issue is to find out the specific IP configuration of the variously affected hosts. Sometimes this information is already known when addressing is configured statically, but when a dynamic addressing method is used, the IP address of each host can potentially change often. Once again, bring up your command prompt and type in IPconfig for Windows or IPconfig for Linux. Your command prompt should look like this. Here's a bonus network utility you can use, netstat. Netstat displays active TCP connections, ports on which the computer is listening, Ethernet statistics, the IP routing table, IPv4 statistics, for the IP, ICMP, TCP, and UDP protocols, and IPv6 statistics, for the IPv6, ICMPv6, TCP over IPv6, and UDP over IPv6 protocols. Used without parameters, netstat displays active TCP connections. To see the different options for netstat, type in netstat /? In your command prompt. Usually, we would like to see who is connected to our machine. In order to check that, type in netstat-a. Go on, pause this video and try it. Now, let's resolve some issues using the network utilities we discussed. You are trying to connect to the University of the Philippines Open University's My Portal website. However, it looks like you are not connected to the internet and have no network resources. You checked if your cables are connected well, and they are. What should you do next? Step 1. Check the IP addresses, default gateway and subnet mask through IPconfig. Modify the addresses if necessary. It will look something like this. If that does not resolve the issue, proceed to Step 2. Ping the servers by IP address and then the server name to check for DNS issues. If it fails, the problem is an internal DNS issue. If correct response, ping a different website to check external DNS resolution. If external ping works. Step 3. Run netstat-a to see who are connected to the machine and determine if an unwelcome party, for example virus, has gained control. Step 4. To diagnose remaining network problems, run a traceroute between your machine and the internet. Another network problem you may have is a local connectivity problem, specifically on LAN segments such as Ethernet or token ring. Step 1. Check for configuration problems by displaying and examining the IP configuration of the source device through IPconfig. Examine the configuration, looking specifically for the IP address and subnet mask, as in the previous problem. This will yield to two different outcomes. First, if no IP address is configured, verify that this node receives its IP address from BOOTP or DHCP. Otherwise, an IP address should be statically configured for this interface. Configure an address if one is not present. If the source is configured to receive an IP address via DHCP or BOOTP and is not receiving one, make sure that the BOOTP IP helper address is configured on the router interface facing the source device. Second, if the incorrect IP address, subnet mask, or default gateway is configured, verify that this node receives its IP address from BOOTP or DHCP, and then contact the DHCP or BOOTP administrator. Ask the administrator to troubleshoot the DHCP or BOOTP server's configuration. If the address is statically configured, configure the correct address. Step 2. Check for local connectivity. If the destination is on the same subnet as the source, try pinging the destination by IP address. If the destination is on a different subnet, then try pinging the default gateway or appropriate next hop obtained from the routing table. If the ping fails, double-check the configuration of the next hop router to see if the subnet and mask match the source's configuration. If the configuration is correct, check that the source or next hop router is capable of pinging any other device on the local LAN segment. If you cannot ping the next hop address, and if the next hop address is an HSRP virtual address, try pinging one of the next hop router's actual IP addresses. If the actual address works but the virtual address does not, you may be experiencing an HSRP issue. Failure to communicate with some or all devices on the LAN segment could indicate a physical connectivity problem, a switch or bridge misconfiguration, or a duplicate IP address. To rule out duplicate IP address, disconnect the suspect device from the LAN or shut down the suspect interface and then try pinging the device from another device on that same LAN segment. If the ping is successful, then there is another device on that LAN segment using the IP address. You will be able to determine the MAC address of the conflicting device by looking at the ARP table on the device that issued the ping. Here's another bonus network utility. Address Resolution Protocol or ARP. It determines the MAC address based on an IP address. The term address resolution refers to the process of finding an address of a computer in a network. The address is resolved using a protocol in which a piece of information is sent by a client process executing on the local computer to a server process executing on a remote computer. The information received by the server allows the server to uniquely identify the network system for which the address was required and therefore to provide the required address. The address resolution procedure is completed when the client receives a response from the server containing the required address. Going back to the problem, to see the ARP table of the device that issued the ping, open your command prompt and type in ARP-A. Here's what it will look like. If at this point you still do not have local connectivity for either the source or the next hop router, check your device's physical connections such as cables. The third and last problem we will discuss has been mentioned in the first problem, but we will dig deeper into it this time: domain name server or DNS problems. It is possible for IP connectivity to work but for DNS name resolution to fail. Most failed name resolution attempts fail in one of two general ways. 1. A user receives a negative response when attempting to resolve a name, such as an error message indicating name not found. 2. A user receives a positive response when attempting to resolve a name, but the information returned is incorrect. Step 1. Ping the destination by name, and look for an error message indicating that the name could not be resolved. Another bonus network utility useful for the next step is NSLookup. An NSLookup looks up information from DNS servers such as canonical names, IP addresses, and cache timers. This is said to be already deprecated, and a better alternative is the Domain Information Group or DIG, which is more advanced and detailed. For the purposes of this tutorial, and if you are a Unix user, an NSLookup would be enough. Going back to the problem. Step 2, enter NSLookup in the command prompt to perform a DNS lookup on the destination. Here are the possible results of the NSLookup. 2 results. Step 3. First result, if DNS correctly resolves the host's name. 1. Try to ping from the source to destination device by IP address. If the ping fails, verify that you are using the correct address, and try the ping again. 2. Try to ping from the source to the destination device by name. If the ping fails, verify that the name is correctly spelled and that it refers to the destination device, and then try the ping again. Second result, if DNS does not correctly resolve the host's name, proceed to Step 4. Determine which name server you are using through IPconfig. Verify that you can ping this name server using its IP address. Step 5. Verify that you can resolve names within your domain. For example, if your host is host1.test.com, you should be able to resolve the names of other hosts in the test.com domain, such as host2.test.com, and outside your domain. Step 6. If you cannot resolve names from all domains except that of the destination, there might be a problem with the DNS for the destination host. Contact the administrator of the destination device. If you cannot resolve names within your domain or a large number of external domains, contact your DNS administrator because there may be a problem with the local DNS, or your host could be using the wrong domain server. We discussed network utilities, the network problems they resolve, and the steps to take to solve these problems. Here are the references used in this tutorial. Thank you for watching.